welcome to another Maths with Paddy video where we talk about an idea from maths or a theorem from maths and do an example, and I always try to get it done in under 5 minutes, okay? So today we're going to look at integration by parts. And we're going to look at the example where we're getting the integral of x by e to the x dx, okay? So we have to figure out what this is, okay? So the formula for integration by parts is the integral of u dv. So u dv is equal to u by v minus the integral of v du. Okay, so in this example, we have to choose what u is going to be, and then we have to choose what dv is going to be. Okay, so we make this choice so that the integral that we get is simpler than our initial integral. Okay, so um, the choice that we have allows us to let u is equal to x. If we let u is equal to x, that will produce a simpler form when we apply the integration by parts formula. So I'll show you if we chose the reverse later on and how we get a more complicated scenario. So if u is equal to x, du, okay, is then equal to dx. That can be thought of as if we differentiate across with respect to x, we'd have du dx is equal to 1, multiply across by dx, and we get du is equal to dx, okay? And then we also let dv, okay, is equal to e to the x dx, okay? And if we integrate both sides, we will get v, and the integral of e to the x is just e to the x, okay? So e to the x. So then we can just apply our integration by parts formula, which is x by e to the x dx. So our formula says uv, so u is x, okay? Our v is e to the x, okay? And we will subtract the integral of v. Well, what is v? It's e to the x, And what is du? Well, du is just equal to dx, so we can fill that in, okay? And then this is just equal to x by e to the x. The integral of e to the x is just e to the x, okay? And we never forget our constant of integration, c. So that's the integral there. So I'll just get a new slide here. Okay, so just give me a moment. So new slide, okay. So let's see what happens if we chose something different, okay? So basically, if we decided if, okay, u was equal to e to the x, okay? Well, if u is equal to e to the x, okay, differentiate across, and the derivative of e to the x is e to the x. So we'll end up with du is equal to e to the x dx, okay? And this will force dv to be equal to x dx, okay? So integrating both sides, we'll get v is equal to, using the power law, x squared all over 2, okay? So then we apply the formula for the integration by parts. So the integral of x by e to the x dx would be equal to u, which is e to the x, u by v, which is x squared over 2, and then we subtract the integral of v du, which is x squared over 2, okay? And du is equal to all this here, e to the x dx, okay? So we get e to the x dx, okay? So this here is obviously more complicated than what we started with, so it results in a situation that's not a simplification. Okay, so this is a more complicated scenario, and this is why we don't make that choice and we make the other choice. Okay, so this is more complex. Okay, so hope that helped you with getting to grips with the integration by parts formula. See you next time. Thanks a million, Paddy.